Hi everyone. In this video we're going to discuss how to use the fundamental theorem of calculus. Before we get started, I want to actually go over the definition, what it means. Now, what they're going to ask you is they're going to ask you to find the integral. Remember, the symbol right here means the integral. They're going to ask you to find the integral of your derivative. Anything that's inside of this integral is always your derivative every single time. Now remember, before, whenever they asked you to actually solve for the integral, they wanted you to find the antiderivative. They wanted to go back to the original function. But now they're introducing an a and a b. Your a is considered a lower bound, and your b is considered an upper bound. Now anytime you have a lower bound and upper bound, what that means is they want you to find the area of this derivative from a to some b. Now, in order to actually find this, you have to find the antiderivative. So you're going to find the antiderivative of f of x, which is capital F, but then your next step is to plug in the b, and then plug in the a, and then subtract those two answers. So you're going to find the antiderivative of the derivative, and then plug in b, and then plug in a into your antiderivative, and then subtract those two answers. Okay? So we're going to go ahead and get started. Our first example is the integral from 1 to 3 of 18x squared. Remember, 18x squared is a derivative. So we want to find the antiderivative. The antiderivative of 18x squared is 18 x cubed, because you add 1 to the exponent, over 3, because you have to put that exponent on the bottom. Now this simplifies to give you 6x cubed. Your next step is you can't forget about your lower upper bound. So they're going to introduce this bar. You're going to put your upper bound up here and your lower bound here. Now we can't forget that our goal is to do f of b minus f of a. So we have to plug in this 3 and plug in this 1. But the thing is, I don't really care about this constant. So what I'm going to do is I'm going to pull it to the side. I'm going to do 6 parentheses x cubed 3 to 1. And that's because I don't really want to work with this 6 yet. So my next step is actually plug in this 3 and then plug in this 1. So when I plug in this 3, I'm going to get 3 cubed minus 1 cubed. And that's because 3 f of b minus f of a. Your upper bound minus your lower bound into your antiderivative. 6, 3 cubed is 27, minus 1. And that's going to equal to 6 times 26. And this is when you actually have to work it out, and you're going to get that this is going to be 156. Now what this means is you just found the area underneath the curve from 1 to 3 of 18x squared, and it gave you an answer of 156. That means that your graph is going to be predominantly above the x-axis. Okay? Let's do another one. From 0 to 3 of 4x cubed minus 3x squared. So before I get started, I know that they're trying to ask for the area because the integral from the lower bound to the upper bound is the area underneath the curve. So they're asking me for the area underneath the curve of 4x cubed minus 3x squared. So what you want to do is just go ahead and find your antiderivative. 4x, add 1 to the exponent, put it on the bottom. Add 1 to the exponent, put it on the bottom. X to the fourth minus x cubed after you simplify it. And your upper bound is 3, your lower bound is 0. And you have to write that bar. So next thing is plug it in. So you're going to have 3 to the fourth minus 3 cubed minus, and I know if I plug in 0 into here, it's going to give me 0, but if you know that, then you don't have to write this out. But if you don't, then just work it out so that you can actually see it. Now when you work this out, 3 to the fourth is going to give you 81 minus 27, and then this all gives you just 0, so minus 0. Now 81 minus 27 is going to give you a 54 minus 0, and this gives you 54. So that means what you just found the area underneath the curve from 0 to 3 of this equation, because remember this is your derivative, and the area underneath the curve is 54. Alright, and the last thing I want to do is I just want to introduce a concept that's sometimes brought into finding the area underneath the curve, and that's when your lower bound and your upper bound are switched. So for example, let's say this is 4 and this is, we'll keep it simple, so we'll just do 0 of 2x. Something basic. Now I know something's wrong because my lower bound is actually not my lower bound. My lower bound is actually my upper bound. 4 is greater than 0. So what you have to do is anytime you have a problem like this, you're going to switch these. You're going to make your lower bound 0 and your upper bound 4. 2x, 3x. But the thing is, you can't just do that. What you actually have to do is you have to put a negative on the outside. So you're able to switch your lower bound and upper bound as long as you just switch them and put a negative on the outside. Then once you have a negative on the outside and your lower bound is actually lower, then just work it out. Negative 2x squared over 2 when you find your antiderivative. This gives you negative x squared. Upper bound 4, lower bound 0, and then you can go ahead and actually find your answer. I'm not going to worry about the negative because it's just a constant. 4 squared minus 0 squared. Once again, if you know that it's going to be 0, you don't have to write it. And that just gives you negative 16. So that means that the area from 4 to 0 of 2x of your derivative was negative 16. Hope this helped. Thanks for watching.